So the last time I saw you, we were talking about fractions, right? And we were talking about adding and subtracting fractions that had the same denominator. So you can probably guess that we are going to talk about adding and subtracting fractions that have different denominators today, right? Remember, the denominator is the bottom part of the fraction, right? The numerator is the top part, and the denominator is that base, that bottom part of the fraction. And when we add and subtract fractions, we have to have the same denominator. And so today we're going to talk about how we find those same denominators, right? And if you see right here, we have to start with what we call the least common multiple. And that's what we're going to do to get our denominators, is we're going to find the least common multiple that the denominators have in common. So if you look here, it's talking about least common multiple, and it says in order to add or subtract fractions with unlike bases, that means different denominators, you need to find the least common multiple of the denominators. Now, the way to find the least common multiple is to look at the two numbers. So if I have 2 and 8, right? These numbers are clearly not the same. 2 and 8 are clearly not the same number. So the first thing I want to look at is, does 2 go into 8? Like if I divide 8 by 2, will I get a whole number answer? Will I? 8 divided by 2?
Yeah.
Yeah, I get 4, right? So I know 2 goes into 8. So our least common multiple on this would be 8. Oh, I was trying to write with the eraser. I'm like, why isn't it writing? So for 2 and 8, my least common multiple is 8. But if I look over here at 3 and 5, if I divide 5 by 3, I don't get a whole number answer, right? It doesn't divide evenly into 3. So the next thing I would do is I would look at 5 and I'd multiply it by 2, right? And I go, okay, well, 5 times 2 is 10, and 3 doesn't go into that either, right? Yes, Leah.
Isn't 5 and 3's least common multiple 15?
Yeah, it is. But why?
So if you multiply them, then you get that.
Dakari?
Because when you put like a chart of their multiples, 15 is the first number that comes up.
Pretty much. You guys have a really good kind of concept of that. I do like the way you guys are thinking. I like to think of it as, if I don't know, right? If that first number, if the two numbers, if that smaller number doesn't go into the larger number, I just have to keep multiplying the bigger number until I find what does, right? Like if I go, okay, well, 5 times 2 is 10 and it doesn't work, but 5 times 3, well, clearly if it's 5 times 3, 3 is going to go into it, right? So we know that 5 times 3 will be our next number. But I can't necessarily, that's not always going to be the case. Like if I look at 8 and 10, 8 doesn't go into 10, right? And so I'm going to try 20. 2 times 10 is 20. Let's try that. 8 also doesn't go into 20. What about 10 times 3? You get 30. Does 8 go into 30? I don't think so, because 8 times 4 is 32. What about 5? 5 is 40. I mean, 4. 4 is 40, right? Does 8 go into 40?
Yeah.
Yeah, because 8 times 5 is 40. And so we know our least common multiple is 40. And we do that with each one of these. 9, 4 doesn't go into 9, right? So 9 times 2 is 18. 4 doesn't go into 18. 9 times 3 is 27. 4 doesn't go into 27. 9 times 4, well, if it's ever just 9 times 4, you know it's going to work, right? If it's ever the two numbers multiplied by each other, it's always going to work, right? And so we're going to say that 36 is our common denominator. But here's 6 and 21, right? 6 doesn't go into 21. I know that because 6 times 4 is 24. So let's look at our biggest number, right? Our bigger number is 21. So 21 times 2 is 42. And I know that 6 times 7 equals 42. So we're going to say that 42 is our least common multiple. And we're just going to keep doing that. 9 and 15. Well, 9 doesn't go into 15. 15 times 2 is 30. Nope, 9 doesn't work there, right? 9 divided by 30 isn't a whole number. 15 times 3, though, is 45. And I know that 9 times 5 is 45. And so we're going to say that that is our least common multiple. Why is it important to know that? Because it'll help us find a common denominator, right? Now, I know you guys have done common denominators before, right? So I know this is just kind of a review for you guys, but I want to make sure that you get it so that you don't forget. The only time you ever have to find common denominators is when you're adding and subtracting fractions. That's it. The only times you ever have to do it. Multiplying and dividing, you don't have to worry about it, right? But when you're adding and subtracting, you always have to find a common denominator. Will you forget this? Probably at some point. And then someone will remind you and you'll be like, oh yeah, I totally remember this now. So we're going to talk now about the rules. Notice I just gave you a page with just nothing but the rules. Why? Because the rules are important when we're talking about adding and subtracting fractions with unlike bases, different denominators. First, if you have mixed numbers, write them as improper fractions. Improper fractions are where the numerator, the top, is bigger than the denominator, the bottom, right? No mixed numbers when you're adding and subtracting fractions. But we know how to do that because we talked about it last week, right? And we had a Delta math assignment about it too. Then we're going to determine the LCM, the least common multiple of the denominators. Rewrite the fractions using there's a lot, this says a lot. It's so much easier to do than it sounds like in writing. Rewrite the fractions using the least common multiple as the denominator. Adjust each numerator to reflect the change in the denominator. I will show you how to do that. Add or subtract the numerators and keep the same common denominator. And then simplify if you can, right? What does that look like? Well, I'm going to show you. Remember that when you do your worksheet, you have to show your work. If I get back pages full of answers and no work, I'm going to send them back to you. All right? When it comes to stuff like this, you have to show your work. I'm going to say, resubmit this. That's what I'm going to say. So let's look at this. We have 11 ninths plus 2/3. We're going to look at number 7 right here. I'm going to even make myself a little bit more room. We have 11 ninths plus 2/3. What do you think the common denominator is going to be on this? 3 goes into 9, right? 3 times 3 equals 9, doesn't it? So we don't really even have to change the 11 ninths because we're going to use that denominator. That's going to stay, right? We're going to say 11 ninths. So what do I multiply 3 times to get 9? 3, I see that, Dakari. I see you.
I don't have that large blank space there.
It's okay. You have it under here. Right? So if I multiply 3 times 3, I get 9. But I can't just multiply the denominator times 3, right? I also have to multiply the numerator times 3. And the reason for that is, what is the fraction 3 over 3? What does it equal? I see that, Jason. I got you. Jason's showing us that it equals 1, right? Any number over itself equals 1, right? Doesn't matter if I have 3 over 3, it equals 1. If I have 8 million over 8 million, it equals 1. If I have 4.2 over 4.2, all equals 1. Anything over itself equals 1. So what happens when I multiply something by 1? What do I get? If I have 5 times 1, what do I get? Show me with your hands. I see that, Caitlin. Right. It equals itself, right? So if I have 5 times 1, I get 5. If I have 20,000 times 1, I have 20,000, right? So the reason we multiply both the numerator and denominator by our least common multiple is that it doesn't change the value, right? When I multiply it, I'm going to get 2 times 3 is 6 over 9, but 6/9 is the exact same value as 2/3. And I'm going to show you what I mean a little bit, right? If I have a pizza and I divide that pizza into thirds, and we'll pretend that these are equal parts, right? And I also divide it into, I have another one just like it, but I'm dividing it into 9 equal parts. This is going to be so much harder, right? Which would mean what? I'd have 2, 1, 2, 3, 4, 5, like this, right? Something like this. That's 6. Okay. If I have 2/3, it's going to take up this much space, right? But if I have 6/9, it's going to take up the same amount of space, right? They're the same. I just multiplied them evenly, but they still, like when we've got the same whole, they're taking up the same amount of space. Does that make a little sense? So 6/9 is the same as 2/3, but now we have common denominators. And when we have common denominators, now we can just add or subtract. So now I have 11 plus 6. Well, that's 17. And our denominator stays the same. And so here I would have 17/9. Now I did the work for that one up here, but you guys could have done it down here, right, on your notes, which is fine. Let's look at number 8. We don't have any mixed numbers, so we're just going to have to find that least common multiple. I have 4 and I have 7. Well, 4 doesn't go into 7. 7 times 2 is 14. 4 also doesn't go into 14. 7 times 3, well, that's 21. 4 doesn't go into that, right? We've got 20 and we've got, yeah, we're going to have to just multiply the 2 together. Well, what that means is I'm going to have to change both denominators, right? So I'm going to have to look at my 3/4 and I'm going to multiply that times 7 over 7. And then I'm going to take my 9/7. And what am I going to multiply that by? 4 over 4. Right? Does that make some sense? So 7 times 3 is 21. So I have 21 over 28. Plus 9 times 4, well, that's 36 over 28. And then I could just add those together. My handwriting looks terrible today. So 21 plus 36, that is 57 over 28. Do you have to put that in a mixed number? No. If you do, will you be wrong? No. But you don't have to do that extra work if you don't want to. What you do have to do is if they're both even numbers, right? The numerator and the denominator are both even numbers, you're going to simplify it, right? At least divide each one by 2, right? Until you can't do that anymore. Number 9, well, we got some stuff going on here. We got that negative, but that doesn't hurt us at all, right? We know how to deal with integers. But we have to figure out what our least common multiple is going to be for 6 and 8. Now, I know that 8 times 2 is 16 and 6 doesn't go into that. And 8 times 3 is 24 and 6 does go into 24, right? So we're going to make our least common multiple 24. So I'm going to have minus 5, 6. What do I multiply 6 by to get 24? I see you, Daniel. I see you. You are right. Daniel says we have to multiply it by 4 over 4. And then we're going to go plus 3/8. What do we have to multiply 8 by to get 24? I see you again, Daniel. Daniel says we multiply it by 3 over 3. And that's going to give us our new problem. 5 times 4 is 20 over 24. Notice I put that minus there, right? Because we don't want to lose track of the fact that that's a negative. And then we're going to go, okay, plus 3 times 3, well, that's 9 over 24. And now that we have those common denominators, those common bases, we know that that's going to stay the same. It's just going to be 24. We just don't know what we've got here yet, right? So I have minus 20 plus 9. So we'll go 20 minus 9 is 11. And we'll give it the sign of the bigger number, which is negative 11/24. Right? So after that, once we find our least common multiples, right, those common denominators, all we did was add and subtract like we did with integers, right, where we had the plus and minus rules. And did you guys follow that one? What happens when I have, like on number 10, where I have a whole number? I have negative 12 plus 7/5. What would be the fraction for negative 12? Anybody know that one?
Not really.
Anytime you have a whole number and you want it to be a fraction, you can just write it over 1. We could rewrite this as negative 12 over 1 plus 7/5. Right? Any whole number, its fraction form is just that over 1. So what would our least common multiple be here?
Wouldn't it be 5?
Yeah, absolutely. It would be 5, right? It's the only one that we can multiply something by. So the good thing is we can leave the 7/5 alone. What do I have to multiply negative 12 over 1 times? Right, 5 over 5. Yeah. So I've got minus 12 over 1 times 5 over 5. And it is going to give me 12 times 5 is 60. So it's going to give me minus 60 over 5 plus 7/5, right? And now I can solve this problem, right? Because we have the same multiple. I know that it's going to wind up being something over 5. And I also know because the 60 is bigger than the 7 that it's going to be negative. So I'm going to go 60 minus 7, which is 53. And I'm going to have minus 53 over 5. Do I have to make that a mixed number? No. Save yourself the extra work. You can make it a mixed number. You won't be wrong, but you don't have to do that extra work. Okay? The next ones we have mixed numbers, right? So we have to turn them into improper fractions first. If we go back up to where our instructions were, it's the first step is to write all mixed numbers as improper fractions, right? And so we are going to have to start with that on this because we have 2 mixed numbers. So if you remember, what we do is we multiply the mixed number times the denominator. So we have 2 times 3 plus the numerator. 2 times 3 is 6 plus 2 is 8. So I have 8 thirds. That's really sloppy. Let me write that nicer. We have 8 thirds plus, well, 6 times 8 is 48 plus 1 is 49, right? 6 times 8, am I right? Is 6 times 8 48? I think so. 6 times 8, yeah, because 5 times 8 is 40, so 6 times 8 is 48. Plus 1 is 49, so we have 49 over 8. So now we just have to figure out what is our common denominator going to be? What is the least common multiple between 3 and 8? And I think that it is 24. I think it's 3 times 8. So that means I've got to go 8 thirds times 8 over 8, right? Plus 49 over 8 times 3 over 3. And we are going to get, I don't even know what we're going to get. I know, I'm going to move it up here because I'm running out of room. 8 times 8 is 64. So I'm going to get 64 over 24 for starters, right? 49 times 3 is 75 minus 3, that's 72. But if you don't know that, you could figure it out on your own, right? You could get a calculator or you could kind of write the math out. 72 over 24. So we got some big numbers going on. Wait, 49. Oh, gosh, I did 25. It's not 72. I was doing 25 times 3, not 49 times 3. 49 times 3, 50 times 3 is 150. 150 minus 3 is 147. So that's how I figured that out. So it's 147 24s. My 4s keep looking like 9s. You guys are so much better at writing stuff on the internet than I am. I'm not good at these like tablets.
Well, we're used to it.
I know the benefits of being young. So now we have 64 plus 147. I think that's 211. It's 211 over 24. That isn't an even number over an even number. So if you want to leave it like that and not reduce it, I don't even think it reduces. So you guys would be okay on that. That's the ugliest problem we've had, right? The rest of them haven't been that bad. But it wasn't hard to find the least common multiple, right? The hardest part was that we were dealing with big numbers on top. But we can add 64 and 147, right? This is 7th grade. You guys got this down. It's just adding, right? The hardest part is that you have to do all that work to get the least common multiples. I'm with you. It was a lot of numbers. I think I'm just going to do one more, which means that that's all you guys will have to do on your notes too, right? I'm not going to make you do those, but we will go over one of the application problems too. Maybe, depending on how much time we have. The reason I want to go over this one is you have that minus and a minus. So that's going to become a plus, right? If you remember our integers, when we have the minus next to the minus like that smiley face, it's a smiley face because it becomes a plus. So first things we have to do, we have to get rid of these mixed numbers, right? So I've got 5 times 8 is 40 plus 1. So that's going to be 41 over 8. I have the 2 minuses. So I'm just going to right now make that a plus and get rid of the 2 minuses altogether. 1 times 20 is 20 plus 1 is 21 over 20. So we don't have anything negative anymore, but we do have to find a least common multiple. I think that multiple is going to be 40 because 8 times 5 is 40 and 20 times 2 is 40. So that should work, right? So we can rewrite that as 41 over 8 times 5 over 5, right? Because it's 5 times 8 equals 40. Plus 21 over 20 times 2 over 2. Notice I'm using the dots for the multiplication. You want to get used to using that for multiplication instead of x because you're going to see it all the time from now on. 41 times 5. I don't even know what that is. Yes, I do, because lucky for me, I have it written down here. So 41 times 5 is 205. But if we don't know that, we have calculators and we know how to do arithmetic. Over 40 plus 21 times 2 is 42 over 40. And we get 247 over 40. Does that reduce? Maybe. I don't know. But if it's not an even number over an even number, I am not concerned about whether or not you reduce it, right? If it was 248 over 40, I expect you to at least divide it by 2. But otherwise, this is a sufficient answer. You do not need to find the mixed number. So I'm not doing number 14, but if you notice, when we look at number 14, we have that minus minus. So it would become a plus, right? Keep that in mind when you do those minus minuses right next to each other. You know what? I think we've had enough, right? Do we really need to do the application problems today? We're going to cross off the application problems. So when you do your homework, you don't have to do the application problems on there either, okay? I will make sure and change that instruction in the thing. Also, let's only do the odd numbered problems on your worksheet. Let's not do the whole worksheet. Let's just do the odds. Okay, I'm going to go in and change the instructions on your homework assignment to only do the odds on the worksheet. I'm making myself a note so I don't forget. Odd numbers on the worksheet and no application problems.
Yay.
All right, so you don't have to do the word problems and you only have to do the odd numbered regular problems. All right, so that just cut your homework like more than in half. But you do have to show me your work. All right, you have to do your work in the box. Don't just give me answers. Show me how you set up those problems, okay? Yes, Jackson?
Do we have to create our own because the PDF's not what it's supposed to be?
The PDF isn't there?
It's like
Is it not letting you create it?
I could show it.
I'll get it. I'll bring it up.
Okay.
I might have just not clicked the button because when I'm setting it up, I'm supposed to click a button. And I'm
It's still a worksheet.
the worksheet one. Oh yeah, you're supposed to create your. Hold on, let me fix that. Oh man,
Yeah, because I got confused when I saw it.
I'm glad you told me because that would have made things so much harder. We want different base fractions.
And then we wouldn't get it done.
We don't want. We want students can view file. Yeah, you might. I don't think it's going to let me now. If you view it, well, try it now. Reset and try it now. See if you can at least make your own copy. If it doesn't, I'll just delete the assignment and put in a new assignment. But
No, this is what I'm trying to say. Maybe I can just present it to you on my
I
screen.
think I know what you're saying is it's not just forcing you to make your own copy like normal, like with the notes.
Yeah, because you know how it's underneath the add above the add or create button.
Yeah.
That's not it's not though. It needs to be right though.
Yeah, I think it's going to make me delete the assignment and then repost it. But that'll only take me a minute. So I'm going to do that. I'm going to just go ahead and delete it. And then I'll create a new assignment in there and it should be fine. Okay.
Right.
So when I create it, here, I'll do it right now so you can see. Create assignment. Shoot, I got to get my printer, my keyboard back. So I'm going to put in worksheet. Maybe. Adding and subtracting fractions with different base. And I'm going to spell different, right? Even though I'm a math person, so I don't have to know how to spell. That's a lie. I do have to know how to spell. We're going to put in here, right? Show your work. I should stop recording. It's going to be a long video.